Today, on how it's made. Mini GP motorcycles. Fig cookies. Toolboxes. And pipe bends. They're called Mini GPs, pint-sized motorcycles whose design is identical to that of the full-size motorbikes that race on the Grand Prix circuit. Mini GP motorcycles are designed for kids 9 to 12 years old who aspire to one day race the big bikes. A Mini GP can reach speeds of 130 kilometers per hour. Its chassis is made of steel tubing to which they mount the handlebars, along with the clutch and brake levers. At both the front and back of the chassis, they attach a fork. Then between each fork and the chassis, they mount a shock absorber. With a steel pin, they mount a wheel on each fork. The black circle at the center is a brake disc. Next, they install a brake caliper on each wheel. When the rider applies the brakes, the caliper grabs the brake disc, immobilizing the wheel. Now, mechanics begin assembling the engine block. Using a special tool, they install bearings that enable the gear shafts to turn. The engine has 6 gears, each of which is comprised of several steel gears. These go into the gearbox. Next comes the gear shifter. It connects the gears to the gear pedal that the rider operates with his foot. Next, they install the crankshaft. The combustion cycle rotates the crankshaft, which turns the gears. They close up that side of the engine, then assemble and install the desmodromic spring. When the rider selects a gear, this spring keeps it locked in position until the rider switches gears. The engine turns a drive shaft that, via this pinion gear, moves a chain that turns the rear wheel. On the other side of the engine, they assemble the primary couple and the various components that go into the clutch, such as clutch plates and the springs that stop and start clutch movement. When combustion drives the piston up and down, it rotates the crankshaft. The primary couple transmits power to the gearbox and clutch. This is a one-cylinder engine. They install the piston that drives the crankshaft, then mount the cylinder over the piston. They close up the cylinder with a cylinder head, then mount the spark plug that ignites the fuel mixture, driving the piston up and down. A head cover closes everything up. Next, they install the ignition. It consists of 2 magnets called a rotor and a stator. When the rotor turns, it generates an electrical charge that sets off the spark plug. Time to install the finished engine. They mount it to the chassis with support pins, front and back. Next, they install the water pump that prevents the engine from overheating, along with the belt that drives the pump. Then they mount the carburetor. It mixes the fuel entering the engine with just the right amount of air. Next, they install the air filter. It keeps out debris that would clog the engine. Now the exhaust pipe, the fuel tank, the seat, and the fairing, a plastic enclosure that shields the driver. The final component is the chain connecting the drive shaft to the rear wheel. The engine turns the shaft, which turns this chain, which rotates the rear wheel. Mini GPs come in different sizes. This particular model has a 50cc 14 horsepower engine. Pretty impressive for a kid's motorcycle. The fig cookie is one of life's sweet mysteries. Who hasn't wondered how they get the figs in that seamless pastry wrap? It turns out that the automated system for producing fig cookies actually dates back to 1891, and it's what makes the fig cookie a snacking success. Fig cookies are a modern way of packaging a fruit which has been consumed for millennia. Making the fig cookies pastry wrap begins with bags of sugar, which they empty into a big mixer. A couple of buckets of corn syrup follow. Then they add an emulsifier called lecithin and some vanilla flavoring. The bowl tilts up for a quick mixing. A worker adds organic bread flour and leavening ingredients to the mix. They reactivate the mixer, which blends everything into a thick, sticky batter. Once properly mixed, they transfer the batter into a large holding tank. Meanwhile, they prepare the fig filling. A worker loads big blocks of figs into a mixer, then adds a generous amount of crumbled cookies for texture and flavor. They mix the two ingredients, then pour in corn syrup to add moisture and sweetness. They add some salt and give the batch another quick mix. They sweeten the fig mix some more by adding plenty of sugar. And now the jam for the center of the fig cookie is complete. The fig jam and the pastry are now positioned for a merger. It will be a neat trick, and a special piece of equipment makes it possible. It's essentially a funnel within a funnel. Rollers press the jam through the inner funnel while pushing the pastry through the outer one, encasing the fig filling in a seamless pastry jacket. Here's the process in action. The system generates long rows of fig-filled dough. And that's how they get the fig jam in the pastry. Next, a technician carves through the dough and removes a few uncooked fig cookies. It's time for a quick weigh-in. This confirms that this batch of fig cookies will be exactly the right size. Now it's into an oven that's longer than a bowling alley. It bakes and browns the fig-filled ribbons of dough. Here, a roller compresses the baked cookies so they'll fit into packages later. An ultrasonic frequency makes this blade vibrate for a clean cut as it carves the rows of fig-filled pastry into cookies. The fig cookies are still a bit warm from baking, so now they chill out on a trip through a freezer. This cool down avoids condensation problems after packaging, preventing mold growth. The trip through the freezer also firms up the fig cookies, so they're less likely to crumble during handling. As she packs them, this worker examines each fig cookie for imperfections, and there's not one reject in the lot. The next step is packaging, where a machine parcels up the snacks. It moves trays full of fig cookies into a sleeve of metallic film. Finally, rotating jaws heat seal the package at both ends. It's taken about an hour to make this package of fig cookies, and it's about time for a snack break. If the crowd is hungry, the whole package could be gone in minutes. But that's the way the cookie crumbles. Thinking inside the box can be a good thing if you want to organize your tools. And of course, we're referring to the toolbox. Proper tool storage keeps any worksite running smoothly and efficiently. And today, you can really go big on the concept with units designed for mechanics and other pros. With a professional toolbox, you'll never have to rummage around for the tool you need. There's a place for practically everything in one of these mega tool chests. It starts with a coil of heavy-duty steel. It unwinds into a punch press that cuts the metal into panels and punches holes for later assembly. Each of these panels will be transformed into a toolbox drawer. They feed the panels into an automated bending machine. It folds them on 3 sides to create the back and sides of the drawer. It also folds over the rim. This adds strength to the drawer and gives it a smooth edge. The assembler slides the front panel onto the drawer, then an automated welding gun reinforces the seams and secures part of the lock mechanism. To build the toolbox cabinet, a worker arranges stiffeners and lock bar grids on the back wall. Then it's over to a lineup of computerized welding guns. These guns fuse the stiffeners and grids to the panel. Each part gets numerous welds to ensure the unit really holds up. The cabinet's sidewalls are next. Workers prop them up with supports as they weld the panels to the back wall. With the toolbox right side up, they install the top. They turn the cabinet around and, working from the open front, slide the lock bars into their slots. Then they build the front framework and weld ledges for the drawers to the support grid. They add a panel to the bottom end of the cabinet and weld the entire perimeter. Now it's into the paint booth, where spray guns coat everything in a layer of powder paint. The paint is tough and solvent resistant, so it will hold up to oil spills in a garage environment. They install the rest of the locking mechanisms on the front of the cabinet. Then, using a guide, press the adhesive-backed logo into place. They now snap the drawer slides into holes on the cabinet's side walls. These slides are equipped with roller bearings, which will enable the drawers to open and close smoothly. Here, they make use of the holes punched into the drawers earlier. A quick click, and the drawers are fastened to the slides. The drawers come in a range of sizes to accommodate tools of different proportions. The shallow compartments will hold wrenches and screwdrivers, while the larger ones have been made for the big power tools. Workers now encase this mega tool chest in plastic and cardboard. But this job is not quite wrapped up. They tip the unit on its side and send it down the line to get wheels. The pre-packaging prevents dents and scratches along the way. A worker bolts casters on each corner of the cabinet to allow it to be easily moved around in a garage or any other work site. Add-ons can be purchased for these tool chests, so the storage possibilities are virtually endless. And that's an organizational approach that you can't really mess with. Natural gas and crude oil travel worldwide through underground and undersea pipelines. These rugged pipes are manufactured in straight lengths, but of course a pipeline's route never runs in a straight line, so every turn or change in elevation requires a piece of pipe that's bent. This factory specializes in bending steel pipe, which is manufactured in straight lengths. A piece of pipe is typically 12 meters long and weighs up to 20 tons. So workers use a crane to move it from one operation to the next. The first stop is a blasting machine that cleans the pipe. To heat and bend properly, the surface must be clean and uniform. But pipe usually arrives at the plant dirty and wearing a coat of varnish to prevent rusting during transport and storage. The blasting machine shoots grains of steel at high pressure for about an hour. The pipe exits, with its surface now clean and smooth. From the blaster, it's onto the bender, which heats the pipe to about 1,000 degrees Celsius, then makes the bend. A technician installs the induction heating coil. Induction heating allows greater temperature control, which is key to preserving the quality of the steel. The coil doesn't actually touch the pipe because that would cause a short circuit. Next, they clamp a pivoting arm to one end of the pipe, then power up the coil. This generates a magnetic field that produces intense heat. Cold water jets confine it to the target area. As a technician monitors and measures, the arm pulls the pipe through the heating coil at a specific speed, curving the softened steel to the same angle. Water cools the pipe at a controlled rate, a process called quenching. They must control heating and cooling precisely, otherwise the steel will weaken. Once the pipe exits the bender, workers verify the angle again. They also verify the pipe's dimensions to make sure the bending process didn't distort them. Now they cut off the straight ends, leaving just the curved portion. Next, the pipes go into a furnace for tempering, a 10-hour reheating and cooling cycle. This relieves stress in the steel that bending created. After tempering, pipes designed to go underwater go through a second quenching. This gives the steel the right properties to withstand deep seawater pressure. Then, using an ultrasonic gauge, workers measure the thickness of the pipe walls, which changes with bending. After another trip through the blast cleaner, workers apply a liquid that highlights even the most minute surface cracks that bending can induce. If they find cracks, they scrap the pipe. But defects are rare because the factory first performs test bends on sample pieces of pipe, then subjects those samples to a battery of tests. The lab measures dimensions and wall thickness, then tests how much weight the sample can support before collapsing, and how much stretching it can withstand before snapping. Back on the factory floor, the pipe goes through another blasting. Then workers heat it and spray on a protective coating that prevents corrosion. It melds to the hot pipe. Once the pipe cools, they stencil on technical specifications. Then these pipe bends go off to join their straight counterparts.